So inside of our class, we have fields, first name, last name, student ID, birth date, look like variables. We create an instance of a student, comment that out, we have student 1. We can do student 1, which is the name of our instance, dot, and I know it's small and I can't zoom in, I apologize, but you'll see birth date, first name, last name, student ID. There's this little blue dot next to them. Those are your fields. We can manipulate the values of those. We can say first name equals Kevin. Student 1 dot last name equals Gantos. Student 1 dot student ID equals M0000. Student 1 dot birth date equals new date time 2001-01-01. That's not my birthday. And we've stored these values. No big deal. So now we can take our student 1, and we can pass him to a function. We can write him to a database with the right type of work. We can package him up into JSON, send him as a web request. We can write it to a text file if we really wanted to. We can do all kinds of different things. Because we now have this unit of data, this student, that has a name, a birth date, and a student ID number. You're not dealing with first name variables, last name variables, you're dealing with a student. The problem here is, what if some of this data is secure? So think back to your database class, you create tables. What is the one most important field in every table? Primary key. If you take a row of data out of a database table and you package it, so let's say you have a table called students, you have fields, columns in that table, you have a first name column, a last name column, student ID column, birthday column. You take one row out of that table and you store it into this student 1 object. I know we're going to kind of mess with convention, but of these 4 fields, which one would probably be your primary key?
Student ID.
Student ID. Do you want people going in, people meaning yourself or another programmer, going and grabbing that row out of the database and then changing that student ID number just by going student1.studentID equals something else and then trying to save it back? What would happen then? You might write over an existing record. So we need to be able to protect this data, protect these fields. And how do we do that? In Java, how did you do that? Please tell me in Java they told you how to do that. What? Private protected. Okay. So we talk about scope, limiting scope. That's the first rule. So instead of making student ID public, we'll go private. So by doing that, you can think of the student class versus our static void main. When things are public, that means that this static void main, it lives inside of a class. Did you notice that? It lives inside of this class called program. Remember how I said everything's going to be a class from this point forward? That's one. This program class can't see the private members of our student class. Even though we created an instance of student down here and we did all of those things, student ID, now that it's private, it doesn't exist. The error says, this is week 14, or it's 15 SS, why did I do that? Anyway, week 1 sample student.studentID is inaccessible due to the protection level. Because we made it private, this class can't see a member of the other class. So we've now protected that number. Good. Good first step. How would we set that value, that student ID, since we've now made this private, but we're taking data from the database? Yeah.
You have to pass it in from the main class to the class.
Okay. And what is the method or methods of doing that?
You have to put a variable, so you would have to put like public class in parentheses in student ID, and then when you declare a new student, you have to pass in the ID.
Okay. But what do I do to actually pass it in? It does, huh?
What's the set method?
A set method? So, public. Go ahead. What am I doing?
You're setting it. Void.
Void.
Set. Name. Are you setting the name?
Student
Set
ID.
student
No,
ID.
student ID.
Student.
Parentheses, and then in student ID.
Oh, but it's a string.
Or string, sorry.
What do I do on the inside?
And then you set the student ID equal to the other student ID.
Okay. Yes, but I don't want to allow people to modify my student ID. Huh? Make that method private?
Or no, I don't know.
Okay. You were like in the back. Huh?
Yeah, that way you make it private to the class.
Make the method private to the class. We could. We could make it private. But this field is already private, so it's redundant. So let's just solve one problem at a time. How do I get this value now that it's private? If my program class, my static void main, wants to actually pull that to print it out on the screen, how do I get that student ID? Yeah.
Like get method,
Okay.
have it return student ID.
What's that look like?
Public string get student ID and parentheses
Okay.
an open bracket or open squiggly.
Yep.
Return student ID.
I like it. Okay. That's how you do it in Java, right? That's what you were taught. Totally works in .NET. Works. Do these get to be a bit of a pain? Having to write a get and write a set and do this whole encapsulation thing and protection gets to be cumbersome. So you have to write this method, you have to declare the private, then you got to write the two methods, work it all together. So obviously we're not doing this anymore. Student1 dot get student ID. And that'll get us that ID. So you end up with all of these. So you end up with all these methods. And you gotta call the method and you gotta do the parentheses. Yes.
So say instead of like making the set ones, like when you for the constructor, you can make it so they put in all the variables at once, and then when you make the new student, you just like throw in the variables.
That's what I was looking for earlier. Yes. So if we want to do a constructor, you guys see that? You saw it. You don't know what happened, but you saw it. If you want to create a constructor for any class, there are what are called snippets in Visual Studio, CTOR, double tab, it'll template out a constructor for you. It basically creates a function with the name of the class. It's not fancy, but it saves you from writing all of that. So now we can come in here and we can extend this and say string first name, string last name, if I can type, string student ID, string birth date. Nope, not string. Date, time, birth date. So then we go through here and do first name equals first name equals last name, student ID equals student ID, birth date equals birth date. Right? So that's our constructor. That's how we get that value in. We don't need that set because that's a security risk. Out. All right. So we've now secured it. What if I told you within the .NET framework there is this thing that gives you security encapsulation. It gives you this get and set functionality, but it feels a lot like a variable. Interesting. Okay. So I kept using the term properties earlier. There's actually a specialized type of member for classes called a property. So to declare a property, there are multiple ways to do it, but the most verbose way to do it involves having a private field, just like we did. So I put a little underscore on student ID because I want that to actually be the name of my property. So I'll do public string student ID. So far looking the same, right? Then you do curly brackets. Then you do get return underscore student ID. It's like a really short get student ID. If we wanted to set it, we'd say underscore student ID equals value. In this context, value is a key word referencing whatever's passed in to this property. So what does this look like? This looks like this code right here. Oh, wrong way. Yes?
What did the underscore do?
The underscore, honestly, changed its name.
Oh, right.
It's a convention that I use, and you'll see it in places where if you have private fields, you notate them as fields by putting an underscore. It's a convention. It's not required, it's not necessary, but it's just something that people commonly do. It helps you with your coding and you're looking at variables to know, oh, that's a field, or oh, that's a property, or whatnot. And if you want to keep your names the same, like student ID versus student ID, it's easy just to shove an underscore in the front. Now, if we come back and we do what we did before where we said student1 dot, of course, so tiny. I will describe it to you for those of you who can't see it. So our fields still have that little blue dot in front of them. It's a square. Our functions have purple cubes in front of them. And that property we just made has a wrench. I did not pick the icons. I don't know why. But it's a wrench. Those are your properties. If we want to make it so that we cannot set that property, because we made it a getter and a setter. If we only want to make it so you can get the value out, you can't set it, you just drop the set. Don't put the set line in there. Then the compiler tells you so. It now says cannot be assigned to, it is read only. So that property is now read only. Alright, so you're like, that's cool, but I still have to do curly brackets, it's kind of a pain, right? It's not that much better. So that was C# version 1.0. Version 3.0, they said, you know what, we could shorten that up. You have to create the private field, and then you have to do all of this work. Why don't we just make it one unit? Because when are you really going to use this underscore student ID? You're going to use it on the constructor, and that's about it. So instead, what they said is let's do this notation. public string, student ID, get comma or get semicolon set semicolon. And this, yeah, we don't need that anymore either. The compiler sees this line of code, verbosely expands it for you at compile time into that other lines of code, and then creates a private variable for you automatically. And then compiles it up so that nobody understands it, only the computer cares, and goes on its way. You're like, oh, that's pretty slick. But it's get and set, they're both public. That's not what I want. If I come over here to set, I can say private set. Now, from the outside, the student ID get is public. I can read from it only. But internally, from the constructor or another method within this class, I can write to it. So typically when you build your classes, I don't expect to see many or any of these fields. I expect to see properties. Now, they're not always going to be public gets and private sets. First name, last name, birth date even. Those are pretty common. They change. No, names don't change, but you get my drift. So instead, just do that. Okay? If you got a whole bunch of them, like you want to store an address, there's a snippet. Prop, double tab, string, street name, prop, double tab, string, street number, prop, double tab, string, tab, city, prop, double tab, string, tab, double tab, state, prop, double tab, string, for not in the United States, string, tab, zip code. So we've now created a series of properties that are public, getters and setters provided. Now what's also the nice beauty about this? Well, right now they're just straight raw values. But what if all of a sudden we realize, people are picking the wrong state, or I'm sorry, they're picking a state within the United States, but they're putting in non-numeric zip codes. That's not right. If you have that case and you need to go back and maybe you need to put some logic in there, because that was really nice with those functions, right? You could write a whole block of code and do some logic to verify the value that was coming in. All you have to do is comment this out, not delete it. You can just put your logic right in there. If state, well, let's do it this way. If zip code is numeric, state, if, no, you get my point. I won't get into that. So we'd write a function to verify that the zip code should be numeric based on the state provided. And if it is, then we actually verify that the value coming in for zip code is numeric only. So the properties give you the ability to, you can go simplistic, do one of these single inline deals, Or you can get very complex and put in some validation logic. Maybe when someone actually goes and sets that zip code or sets that birth date, instead of you waiting for them to call a save command, the moment that your line of code says student1.birthdate equals whatever, it gets picked up and it gets written directly to the database in real time. I'm not saying that's good practice, but if that's what you need, you would want to map that setter straight to that database field. You have that control. You can't do that with a field. When someone sets a field, then you have to have this separate process that goes out and checks to see did that field change, did that field change, did that field change, did that field change, and then trigger that change. Or we get into this idea of events. When this value changes, raise an event to notify another part of your program because it needs to kick off a process. Properties give you that ability to do those types of things. Okay? Any questions around that? And again, we'll get into this. This latter example of doing all of this verbose work, even today, for me, sitting down coding fairly large applications, this happens on occasion. Usually there's better methods to doing it or other ways of handling it, but just knowing that it's there is kind of what I'm shooting for. Well, actually, let's work from where we are. So zip code is numeric, and I'm passing in this state. My intention is for zip code is numeric to be a function. Let's do that. It's an internal function that I'm using to verify. So I'm going to make it private. What is the return type for that function? Boolean. What do they call it? And then what is the input parameter type?
Integer. Is it good?
No, we're inputting the state.
Oh, it's a string.
String. Actually, let's do it lowercase. Okay. So this is the scope of accessibility, just like we did with our properties. Return type, in this case it's a Boolean. The actual name of our function. And then this is the parameter. We can also obviously have more than one of these. Just type name, comma, type name, comma. In this case, we only need one. So within a function, you're basically writing code. You're doing work. You'll often see me write do work. The signature for this function requires that it return a Boolean. Booleans are value types, therefore a value must be returned. To return a value from a function, it's simply return and then whatever that value is. So this is the default. It'll return false. Now we have to do some sort of logic to decide whether or not we should return true. That's our do work. I'll make it easy for now, and I'll say if state equals Ohio, return true. If we wanted to, we could probably get into some more complicated algorithms about having a database table full of states and countries and having those identified with metadata around whether the zip codes are numeric or alphanumeric, and this function goes and makes a call to that table and pulls out all the alphanumerics and does a cross compare with the name of the state to see if it should be alphanumeric or not. We're not going to do that. So, state is a lot. Returns true, otherwise it returns false. Because this function is private, it can only be called by this class. If we come out here, can't do that anymore. I think we got rid of that. We say student1 dot, oh, I already got a student1 up there. There is no zip code is valid because it's private. So from the scope, we can't see, in this class, we can't see that member in that class. If we make a method that's public, as we talked about when we did our get, those public methods can be seen. We talked at one point about that whole by value, by reference. This is where we would go through and do things such as set by reference. So if we wanted to pass that birth date by reference, because it's technically a value type, we would say public void set birth date, ref, date time, new birth date. Now, if in this method we went ahead and decided to change the year, no, we can't because year is get only. So we have to add years. What? Oh, oops, years. There we go. I want it to be 2050. I have to add years, so I have to basically, I want to get to 2050, so I'm just saying take 2050 and subtract however many years are there. And then add those to new birth. So order of operations, right? Execute the stuff in the parentheses and then execute the larger statement. So it's going to do the math first, give me the number of years, and then take that value and then actually add it to new birth date. See, you guys are giving me that glazed over look. It's 7:40 and you're all going. Math. All right. So functions. All right, so the last piece, we will call it a day. I'm going to put my other constructor back just so I don't end up with compile issues. Constructor, boop, thank you. All right. So I started talking about this whole idea of student 1, student 2, blah, blah, blah. What's a good solution to that problem? Instead of creating 23 student variables, what would I do instead? Create 22 student variables. Huh? Create it within a for loop. Okay.
Create an array of students.
Create an array of students, and then initialize it using a for loop. How do you create an array? Hint, it's just like in Java. Go. I got an and I got a hand. Hand wins. Go.
Just say like, was it string array equals or equals new string and then the square brackets. And then semicolon.
I'm just kidding. You got the right idea with the brackets. We want to do an array of students.
Students, bracket. Bracket.
Bracket? I got bracket.
Now, whatever you want to call it. Equals. Something like that. I don't know.
Oh, I dropped my N. It doesn't like that. Oh, I spelled like wrong. That's the problem. Hang on. All right. All right, you're almost there. How many students? Oh, we got hands still. All right, hands, go, let's go. I don't know who was first. You already went one, so you get a chance.
Well, you put how many students you want to make.
How many students?
So you want 23, so you put 22.
I want 23, so I put 22. Or what did you say? I missed it. I want 22, so I want 22.
Oh, do you want 23 or 22?
23.
So
So
you put, is it 22?
Yeah, because
Yeah, because you start at 0, right?
kind of, but I want 23 of them. So I want 23 of them. But it's indexed starting at 0. So it counts from 0 to 22. 0 is the first one, 22 is the 23rd. You can't tell if you're right or wrong, right? That's good. It keeps you awake. See, everybody's re-engaged now. All right. So for loop, snippet, double tab. Here we go. So from 0 to class list dot
Side.
length. So class list. How do I access that first one?
See 0 or square bracket 0.
I.
All right. Well, so 0 is the correct answer because that's how I access the first one. But if I want to access the one in the loop, it's I. So I is my variable that's going to increment. We're going to start at 0 and we're going to count all the way up to the one before we hit 23. So the length is 23. Our array runs from 0 to 22. 0 is the first position, right? So I represents from 0, then it loops 1, loops 2, loops all the way up to 22. So whichever one's the current one, we want it to be I equals a new student. So we've now declared or created an array of students. We've initialized them, so now we have memory address for a student, another memory address for a student, all 23 of them. And they're all empty, not empty, they're not null, they're initialized, they have no value. So then if we want to initialize that first one, I don't know why we do it outside, but let's say we did. Class list 0 dot first name Kevin semicolon class list 0 dot last name equals Gantos. Class list 0 dot student ID. Oh yeah, we can't do that, can we? You get the drift. So that's how we access those individual elements within our array. Now what happens if another student joins this class? Yep.
Use the same logic as you did like in the for loop, but for inside the brackets you do dot length, the array name dot length, and then +1.
So here do dot length +1.
No, like wherever your method is that you're like writing new student information,
Right.
put the same logic as you do for like in the for loop, saying new student,
Right.
and then in the array be like class list dot length +1 inside the brackets.
Okay, but what if I want to make this one bigger?
All you do is change the number.
Change the number. Okay. Correct. What's the problem with this code?
It's not dynamic.
It's not static, not dynamic. Yes. All the above. All right. In Java, how would you overcome this?
While list.
Array list. Was there something else?
While loop, sort of for loop. I mean, if you had a way of seeing how many students you've added. Okay, so
In terms of handling an infinite number, you would probably do something more like a while loop. Okay, but an array list would be the tool of choice. Within the .NET framework, we have array lists. They came out in version 1. They are not, the term is strongly typed, which basically means to you and I that you put something into the array list, it becomes an object in the array list. When you go to pull something back out of the array list, when you say class list 0, give me the first student, it says, oh, okay, here's an object back, and it's your responsibility to be able to cast that back into a student. You also cross your fingers and hope that it is a student. Because if it's not, then you get an invalid cast exception and your app goes. So to overcome that, they created strongly typed collections, and in .NET it's just referred to as a list. So when you guys would create array lists in Java, you do array list, angle brackets, name of the type, right? Your class name. .NET, same idea, but it's just list. So we would say list of student, class list, equals new class list. Now this is a collection, this is a container, it's not an array of items. So you add things to collections. You add items to the list. So we no longer have a length, we now have a count. And if we run this for loop, in this case, it won't run. Like, it'll just skip it. Because I is 0, currently the count of this list is also 0. Because there's nothing in the list. So instead, what we're going to have to do is initialize 24 students into that list. It is almost 8 o'clock, and I am not going to sit here and let you watch me do that 24 times. So instead, I'm just going to do 1. So class list dot add. This is a method. It takes in a student. So this is super shorthand. New student. So I'm initializing a new student. Now here's something to wrap your head around. I'm initializing a student, but I'm not actually storing it inside of the variable itself, right? Normally we do like student1 equals new student. Well, instead I'm saying, in memory, go ahead and carve out that space, like initialize some space in memory for a new student, set it all up, set all the nulls and all the defaults, do all of that work, but instead of storing it in a variable that I have a memory reference to, here comes that by reference thing. Take that memory reference and set it to this input parameter. So just take that memory reference and pass it straight into the function. You get the same net result, but instead of declaring a variable up here and then storing that memory address in that variable, we're just taking that variable which stores the memory address and passing it into the function. We're just taking that and saying, create a new instance of a student, give us that memory address, and we'll pass it straight into the function. That's what we're doing. Now we have two constructors, and if you can see it, there's like this one of two student.student parentheses going on here. If we hit the down arrow on the keyboard, it'll give us the other overload for the constructor. So here we can say Kevin Gantos M000 new, and then we're going to do it again. Here we go. New date time. Got a whole bunch of overloads. I'm going to use the 2001, comma 01, comma 01 overload, semicolon, and I've now added a student to the list. Cool, right? You guys would have done it like 6 or 7 or 8 lines of code, right? So 1, 2 line, I just did it for clarity. So you can use these, you can kind of bundle these or put all these together just to kind of streamline your code. Now, sometimes it makes it more readable, sometimes it makes it less readable. So I can now copy this and paste it 24 times, making the correct adjustments. In a ideal or normal situation, you wouldn't be declaring or initializing 24 students by hand in code. You would probably be pulling them from another source, a text file, a database, an XML document, a web service call, somewhere else that data would be stored. Because you want it to be dynamic, you want it to be retrievable, and the term is serializable, savable. You want to be able to serialize data somewhere else and then deserialize it, bring it back into your application and make it usable. So this line of code would look a little different. It would probably look something like classlist.add equals new student, and then you would insert the object that represents that row from the database. The student class would know how to read that row from the database. It would grab by field the values and store them into the proper properties. The runtime would then take that new student object, pass the memory address for that student object into the list, and the net result would be a list of students loaded from the database. Each row created into a student object, that object then stored into your class list in memory, ready for you to go on to the next step of your application. Yes?
And it's indexed like an array, but it's going to start at 0.
Yes. So to access that item, you would do the exact same work. Class list, 0. This would be Kevin. And then you can go class list 0 dot first name, whatever. Yes. So oh, I didn't mean to do that. And it still says 20. Okay. Are there any other questions?